is a directly proportional relationship? Miss Glover, we did that lesson yesterday. You're right. That's the leading question here for our first part to our lesson today. I just want to back it up. I know you read this. Our goal for today says, I can understand that a relationship is proportional when I see its equation, y equals kx. Yesterday, we talked about how can we determine if we have a proportional relationship by just looking at a table of values or a graph. So now we're adding another layer to that, and it's being able to just look at an equation and go, yep, it's a directly proportional relationship. Here's our first example. We have the equation y equals 3x. We want to know, is this a directly proportional relationship, just looking at that equation? And well, the answer is yes. And I want to give you insight into why. So let's use what we did yesterday. Let's start by taking the information in the table of values and plotting it on the graph. So our first ordered pair is -1, -3. Starting at the origin, I'm going to go over to -1 and down to -3. My next point is 0, 0, the origin. And you might already go, Miss Glover, I remember from yesterday, if the graph goes through the origin and it's a straight line, it is a directly proportional relationship. You're right. So we can even see that from the table. Our next point is 1, 3. So I'm going to go over 1, up 3. Then we have over 2, up 6. And the last point is going to be off the graph. We got 4 points. That's good enough. I'm going to go ahead and connect them. And I can see that, yes, it is a beautifully straight line. I see that linear pattern going right through the origin. It is directly proportional. But remember, today we're focusing on the equation. We just want to be able to look at y equals 3x and go, yep, it is directly proportional. Let's find the slope of this line. So I'm going to pick a point here, right at the origin. How much do I have to rise? 1, 2, 3. To how much do I have to run? 1. Am I running in the positive direction? Yes. Therefore, this is a positive 3 over 1, which we would simplify that to be just 3. All right, Mrs. Glover, nothing is new so far here. You're right, this is what we did yesterday. Also yesterday, we looked for those y to x ratio patterns. That was our constant rate of change within the table that we were identifying. So let's do that again now. Let's take our first ordered pair, which is -1, -3, and let's go y divided by x. -3 divided by -1. My signs for those integers agree. They're both negative, so it's going to be a positive 3. 0 divided by 0, we can't divide by 0. That's a special case. We're just going to skip to the next point. Let's go ahead and let's take our y to x ratio there. What value do we get? 3. Same thing, our next one would be 6 divided by 2. 6 to 2, that gives us a value of 3. And then 9 to 3, that gives us a value of 3. We can see that we have that constant rate of change throughout our table of values. Our y to x pattern is what? 3. There's a lot of 3's on here, isn't there? Look at this. Our y to x pattern, which represents our slope, which represents that constant rate of change within my table. Look where it is in the equation. And we talked about this yesterday. We talked about how we can do our y to x pattern, but we could also say, hey, what are we doing to x to get our y? And here it is. We're taking our x and multiplying it by 3 to get our y value. In our goal today, it talked about being able to see the equation y equals kx. And that's what you do see here, 7th graders. That k represents the constant, that slope, that constant rate of change. So our equation y equals 3x is in that form. Therefore, it is a directly proportional relationship. That was a lot of information and slightly repetitive. Let's do another example together. We have the equation y equals -2x. It is a directly proportional equation. That means our table has a constant rate of change and our graph should be a straight line and go right through 0, 0. Let's make sure that all of that is true. Let's start by graphing this proportional relationship. Starting at the origin, we have -4 up to 8. Since that would take me off of my graph here, I'm just going to choose to leave that one off. Let's go to the next one. Over to -2, up to 4. We have the origin, over to +2, down to -4. And then this last point here would be off my grid, so I'm just going to let that be. 3 points is enough. I'm going to connect it. Now, based off the other day's lesson, I know that this is a directly proportional relationship by looking at the graph. Let's identify the slope. Find a point, figure out how much you have to rise and how much you have to run over to get to the next. I have to rise 1, 2, 3, 4 to go over 1, 2. But I'm going over towards the negatives. So it's a negative 4 to 2, which we always want to check. Can we simplify? Yep, that would be negative 2. Let's make sure our y to x pattern matches our slope. Is the ratio of y to x a constant value? Let's take our first ordered pair and we're going to take our y value divided by our x. You can see that gives us negative 2. My signs don't agree, so my quotient's going to be negative. 8 divided by 4 is 2. 4 divided by negative 2, negative 2. 0 divided by 0, we're skipping that. We can't divide by 0. It's a special case. Negative 4 divided by 2, negative 2. Negative 8 divided by 4, negative 2. We can see that we have that constant rate of change as we move from one point to the next. We can see that our y to x pattern is negative 2. And we can see there are a lot of negative 2's. And this equation right up here, which is our whole goal for today, would be a directly proportional relationship because it's in that y equals constant times x, where k here is representing our constant, which in this case is negative 2. Let's put all of this together. We've seen it in pictures. We've worked through it. Now let's kind of summarize with words. Go to the next chunk in your notes. Graphs of proportional relationships always go through the origin, so 0, 0, and are straight lines. We talked about that yesterday. And in the previous week, we learned that the unit rate of change in a proportional relationship is the same as its slope. We reviewed that yesterday, and we've done it today as well. Next, the slope of proportional relationships is always rise over run, but now we're building and we're recognizing it as the y to x ratio. And then today, this is what we're noticing. All directly proportional equations can be written in the form where we have our y equals slope times x. That's what we had going on in the two examples we just did together. Also working to recognize that equation form can be written as y equals k, which is our constant, it's our slope, our rate of change, times x. Pause the video, make sure you have all this written down. If you have any questions, go ahead and write them on the left-hand side and make sure you remember to ask. We'll dive into some more examples when you're ready. Turn to the back of your notes. We have some examples. I'm going to do the first one with you. Use the given table of values to graph each function, find its slope, and write an equation. So let's do that. Here's our first ordered pair. It's 0, 0. We have our next ordered pair, which is over 2, up 1. Then we have our next one, which is over 4, up to 2. And we have our next one, over 6, up to 3. And over 8, up to 4. Since that goes off my graph, I'm going to choose to just let that one be. I have enough points right here. I'm going to draw my line. So we graphed the function. Now we're going to find its slope. I'm going to pick a point right here, and I want to know how much do I have to rise and go over to get to this next point. So I go up 1, that's my top value, over 1, 2, over 2. And I see that is continuous, right? Up 1 over 2. Here we go, up 1 over 2. I have that beautiful staircase. This is a positive slope. So my slope is 1 over 2, and it is simplified. We need to write an equation for this table, this graph with the slope. We just learned about this equation, that it represents a directly proportional relationship, and that our k is our constant rate of change. It's our slope, right? So let's write this with our slope in there. So y equals 1/2 times x. There's our equation. And we could check that. Let's plug in our x and y pair here into this equation. If I plug, so I'm going to check that right here, okay? Let's plug our 4, 2 pair in here. So when y is 2, x is 4. So 1/2 times 4. What's half of 4? 2, right? We could check that again. Plug 3 in for y, and we're going to plug 6 in for x. What's half of 6? 3. We can see that we wrote the correct equation for this directly proportional relationship. This time, you're going to do the next one on your own. Pause the video and do that now. The equation you should get is y equals 2/3 x. 2/3 represents our slope. It represents that constant rate of change between our y and our x in our table. And I checked it. I picked 2 ordered pairs, these 2 right here. I substituted them into the equation and checked to make sure. This is the correct equation to represent this directly proportional relationship. Go to the next problem. How is this problem different? I'm noticing right away that my table of values is not completely filled in. But I do see that I have 2 points, and I only need 2 points to find slope. And I know that slope, which represents that constant rate of change, is what I need to write my equation. So I'm going to start by plotting the 2 points that I do have in my table of values here. Starting at the origin, I'm going to go over to -2, up to +8. And then I'm going to go back to the origin. I'm going to go over to +1, down to -4. I'm going to try really hard now. I know it's a directly proportional relationship, so it's got to go through the origin to draw my straight line. That was challenging for me. Now we need to know what our slope is. So let's identify how much we have to rise up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To how much do we have to run over? 1, 2, 3. Now, are we running towards the negative numbers? Yes, so this is a -12/3, and can we simplify that? Absolutely, that equals -4. There is my slope. For every 4 I go up, I'm going to go over 1 towards the left. Now I can write my equation, because I know my equation needs to be in that form y equals my constant, or my slope, times x. So we have y equals -4x. That multiplication is invisible in there. Now we can fill in the rest of our table, can't we? Absolutely. Let's plug values into this. When x is -1, what is y? Well, I'm going to plug in -1 for x. What do you get? My signs agree, so it's going to be a +4. Let's plug in 0 for x. Anything times 0 is 0. Thank goodness Miss Kluver got it to go through the origin. And when x is 2, whoopsies, -4 times 2. My signs don't agree, so it's going to be a negative, and then 4 times 2 is 8. So -8. And I could plot those and make sure that they fall on the line, but I will tell you, I know that they do. So what was different with this one? We were missing pieces in our table of values. But remember, all we need to determine slope, which is that rate of change, is 2 points. Here's our last example. Our job is still the same. We need to use the given table of values to graph the function, the relationship, and write its equation. So let's do that. Here's our ordered pair, 1, 12. So starting at the origin, we're going to go over to 1. It looks like our 12 for our y is going to be off, and that's okay. I'm going to say it's about right there. Our next ordered pair is 2, 6. So I'm going to go over 2, up 6. Then we have 3, 4, over 3, up 4. Then we have 4, 3, over to 4, up to 3. And then we have 6, 2. So over to 6, up to 2. Right away, I can tell this is not a directly proportional relationship. It does not go through the origin. And I can see now that I've plotted my points and connected them, it's a curved line. So if you go back to your notes from yesterday and you find where we looked at inversely proportional relationships, it has a curved line not through the origin. Let's go ahead and let's write that on the left-hand side here. We have a curved line not through 0, 0, not through the origin. Looking back at your notes from yesterday again, flip to that. They were the 8-3 notes. You can see that there is no slope for an inversely proportional relationship. No slope, but there is a constant pattern. So is there a slope? Not for a curved line. Let's write that in. So how do we write the equation then, Mrs. Kluver? Well, we do have a constant pattern. And remember, it was where we take our x times our y, we're getting a constant value. So look at this. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. These are all going to have a product of 12 when you take your x and multiply it by your y. We know that our constant is represented by the variable k, right? So k is equal to x times y. But we want to write our equation in terms of what? Y. Y equals. Well, how could I get x out of here and get y by itself? I could divide both sides by x. I'm going to divide by x, divide by x. That's going to give me y. So I can see my equation is y equals my constant divided by x. That is what we're going to use over here. Y equals, what was our constant? What was the constant value we were getting? 12 divided by x. And we could check that, right? Let's pick some points from our graph. We have 2 and 6. When I plug in 2 for x and 6 for y, it would look like this. 12 divided by 2, is that 6? Yes, it is. Let's pick another one, 3 and 4. When I plug in 3 for x and 4 for y, 12 divided by 3, is that 4? Yes. So here, our constant pattern came from taking x times y, which gave us our constant. So our constant, which is represented by k, equals x times y. We wanted to get our equation where y equals. So how do we get the x times the y out of there? We divided both sides by x. So y equals k divided by x is the same as k equals x times y. Here's our equation that we're going to use when we have inversely proportional relationships, and we have to come up with the equation. It's summary time. We have finished our 8.4 lesson. The big thing today was recognizing the equation y equals kx represents directly proportional relationships. K is that slope, that rate of change. But then we also looked at an equation for inversely proportional relationships, and we still have a constant piece in there, k. K is still present, but our equation looks a little different this time. The equation y equals k divided by x represents inversely proportional relationships. Split your summary box and put those two pieces in the two parts to your summary. Have a great rest of your day.